Hi everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look at how we actually change the state of substances. So hopefully by the end of today's lesson you're going to be able to explain how substances undergo that change of state. To start us off, we've got 4 questions based around our previous lesson. So have a go at answering these 4 questions in your books. I'll leave these up for about 4 minutes today. Let's check those answers then. So for question 1, hopefully we got different forms of an element in the same state but with a different arrangement of atoms. 1 mark if you got that definition. Question 2, first mark is for saying that it's got many strong covalent bonds, and the second mark is for saying that they require lots of energy to break. For question 3, first mark is for saying it has delocalized or free electrons. And your second mark is for saying that these delocalized electrons are free to move through the structure. And then finally for question 4, our use of our nanotubes, reinforcing tennis rackets is the most common answer there. So add it up, you've got a total out of 6 today. Now hopefully we do remember that when we discuss a change of state, what we're referring to is a substance changing from the solid to the liquid or the gas state, or from the liquid to the gas or the solid state, or from the gas to the liquid or the solid state. So we're changing between those three states of matter: solid, liquid and gas. What I'd like you to do first of all then is see if you can write in your books what happens when a substance either melts or boils. Now, the key thing we need to know here is when we think about the structure of solids, liquids and gases, we need to go back to the work we did in C1. So think about our particle model of solids, liquids and gases. Now, each of those individual particles is actually held by these bonds. Now, what we find is that when our substance changes from a solid to a liquid, then some of the bonds holding those particles together will break. And when it changes from the liquid to the gas, all of the remaining bonds break. So then we've just got those individual particles. What we do find though is that different substances will actually have different strengths of bond. And the stronger the bond is that's holding those particles together, or the more of them there happen to be, then the greater the amount of energy we have to transfer from the surroundings to our substance in order to actually break them. So what we see here is the reason that different substances have different melting and boiling points, because they need different amounts of energy being transferred from the surroundings to our substance to break either some or all of those bonds holding the particles together. So jot down those 3 sentences in your book if you've not already got them. If we think about a substance that has a high melting point, then we can explain that by saying that it's got many strong bonds in that solid state. So what that means is that the particles that are all held together in that lovely regular arrangement that we know a solid has, then they are strong and there are lots of them. So that means that we've got the need for lots of energy to be transferred from the surroundings in order to break some of those bonds in order to change it from the solid to the liquid. So using that same principle, once you've written down that first sentence, see if you can explain why the substance has a high boiling point. Hopefully we finished off that sentence with some kind of wording to the effect of that a substance with a high boiling point has many strong bonds in its liquid state. Therefore, we're going to have to transfer a significant amount of energy from the surroundings to our substance in order to break all of those remaining bonds to convert it into a gas. So let's see now if we can use that same knowledge about what happens when we're converting from solid to liquid and liquid to gas to explain what's going to happen when a substance condenses or freezes using that idea about bonds. Hopefully we remember that condensing is when we're changing from a gas to a liquid, therefore some bonds must form, and in freezing that's a liquid to a solid, therefore many bonds are forming. So we're then changing it from this more fluid structure to the rigid structure. And in order to actually do this, we're going to transfer energy to the surroundings by heating when those new bonds form. So make sure you've got those written down if you didn't already get them right. One of the common questions you could be asked is they're going to give you a particular temperature that a chemical is found at, and they will give you its melting point and its boiling point. And you'll be asked to predict what state of matter you'd find it in at that temperature. So have a go at this question here. The melting point of bromine is -7 degrees Celsius and its boiling point is 59 degrees Celsius. Predict its state at 25 degrees Celsius. Now, one way that we can do this and visualize it is to basically put our little line that goes from a solid on the left to the gas on the right. So we know the melting point is -7 from the question, and the melting point is where it changes from a solid to a liquid. And we know its boiling point is 59, and that's where it changes from a liquid to a gas. Now, at 25, that's going to sit between -7 and 59, so that means it will be a liquid. What I've given you in the table here then is a summary about the different types of substance that we've encountered through the topic, the type of bonds that we have involved in the change of state there, the relative strength of those bonds, and then examples of the substances that we would find them in. So I'd suggest you start off by jotting down that table because it's a really good reminder of the types of bonds we find in different substances and the strength of them. Once you've got that, then there's 2 questions at the bottom for you to have a go at answering. So hopefully we identified the solids as being the metals, the ionic compounds and the giant covalent structures, and the simple molecules would be the gases. The last change of state we need to be aware of is sublimation. Sublimation is where it changes directly from the solid to a gas. So it doesn't go through a liquid stage at all. It literally goes from the solid straight into a gas phase. And a good example of this is iodine. Now, iodine is made up of these simple molecules, and simple molecules, their particles are attracted by weak intermolecular forces. When they're in their solid state, they're these shiny black crystals, but at room temperature, then they actually get separated because those weak intermolecular forces are overcome and it changes from the solid straight into a gas, and it's a purple vapor you then see within your container. So sublimation is the direct change from a solid to a gas, and normally we'd see this in the lab with some iodine. Final thing for today then are the plenary questions. So those of you with a target grade up to grade 5, 2 columns on the left. Those of you with a target grade over grade 5, it's the 2 columns on the right. So I'll leave these up for about 4 minutes today, but as always, if you need longer to get these done, hit pause and take as long as you need to answer them properly.